So Charles law is telling us that the volume of a fixed mass of gas or a certain amount of gas is directly proportional to the temperature. You understand? Directly proportional to the temperature, provided the pressure is kept constant. So at constant pressure, volume and temperature, we have something in common. And this if the interpretation of this one is like, if I introduce a constant here, so we're having this over k, this over t, then over t, then this goes out, we have what? V over t, and that's what? V1 over T1 in two variables, that V2 over T2. This is the Charles law. You understand? That's the Charles law. That is, for a certain mass of gas, for a fixed mass of gas, the volume is directly proportional to the temperature. That's what the Charles law is trying to tell us there. Now, this is the law. Volume is directly proportional to the temperature as constant pressure. So when it comes to this, we are not going to, pressure is constant, so we are going to be looking at pressure in any form, but we are going to be looking at volume and temperature. Now, the interpretation of this law, the interpretation of this is that, unlike Boyle's law that the volume increases, the pressure also increases, but this time around, it will be like, while the volume increases, the pressure does what? The pressure decreases. That's just the Charles law. So the Charles law is telling us that as the volume of a certain mass of gas, when the volume increases, then the pressure decreases. Then as the pressure decreases, the volume also increases. So that is that. No. So Charles law, the interpretation of the Charles law is that as the volume, the Charles law is the interpretation of Charles law is that as the volume increases, the temperature does what? Decreases, and while the pressure decreases. So that is it. So this one is not like when the volume, we're talking about volume and pressure, that's volume increasing and pressure increasing, but this one, when the volume increases, temperature increases. So it means that if you are looking at some situation, like in the case of bicycle pump, because for Charles law, it shows that when the volume increases, then the temperature decreases, or when the temperature increases, the volume decreases. So that is the law. So what I'm going to do now is to write out the law, and we have a mathematical interpretation of the Charles law. Then we have what? Charles law states that at constant pressure, the volume of a fixed mass of gas is directly proportional to the temperature. Directly proportional to the temperature. And this, so Charles law states that at constant pressure, the volume of a fixed mass of gas is directly proportional to the temperature. And this law is telling us that V1 over T1 equals what? V2 over T2. This is the Charles law. Yes, the Charles law. Then what about the kinetic theory? Using the kinetic theory of matter of gases to explain the Charles law. The kinetic theory of matter in this situation is telling us that if the volume increases, yes, and the amount of particles there, because of the volume, because temperature reduces. So when the temperature decreases, they have the particles there, we have a sluggish flow. You understand? Thereby, because the current, but if the temperature increases, then the average kinetic energy of the particles increases, so they have more random movement, thereby reducing the volume. You understand? So that is it. So this is the concept of you filling the gas at home, because when you fill the gas, we talk about as the temperature increases, the volume decreases. So for kinetic explanation on this, is just telling us that the particles gain more kinetic energy, thereby reducing the volume of the gas. So that is that. Then if we are looking at the mathematical, the calculation aspect of the Charles law, we need to be careful, because of what? So let us, this is the Charles law, and let us look at the mathematical calculations of this. So if you are looking at the mathematical calculations, there are two things here. We have volume. Volume usually in what? cm cube, comma, dm cube, or per liter. You understand? But for temperature, either temperature 1 or 2, for temperature is usually in degree Celsius, but need to be converted back to what? To Kelvin. So if I'm talking about anything, majorly, when they give us a question with Kelvin, with temperature in Kelvin, you can just use it straight like that. But if you have a degree Celsius, they have to be converted. So it means that if I have a temperature of like 10 degrees Celsius, if the temperature is there, then this one needs to be converted back to Kelvin. That's plus 273. This is the standard. That's, we have a 283 K. Be mindful of the unit. So you need to be mindful of the unit of the temperature. So, but if the temperature was given to us in Kelvin, leave it. But it's not given to you. You have to what? You have to do what? Convert this degree Celsius to Kelvin by adding this. You understand? So that is that. And in some situations, they can still give you minus. They can give you maybe minus 5 degrees Celsius. C add plus 273. Then you have your answer. So this is one thing that you need to know before starting the calculations of the Charles law. Let me give us an example. Then we'll use this example to look at that. And I used to tell you, in any exam, nobody will tell you this is Boyle's law, this is Charles law. So what you do is that you look at the question, write out the parameters, then solve. Like for example, now let's look at the first example. Let's say we have 100 cm cube of a gas was compressed at 10 degrees Celsius. Was compressed at 10 degrees Celsius. Then you now say that what will be the volume if the temperature is raised to 20 degrees Celsius. Yes, look at, so this is a typical example, and sometimes used at constant pressure. This question is a confirmation of what? The Charles law at constant pressure. But I've seen questions that they don't put at constant pressure there. I've seen some questions that they don't put at constant pressure. So what you do is that you really want to write out the parameters, write out what you need to identify. I might not be able to identify this as Charles law, just mere looking at it, I might be scared. But if I take a careful look at, let me write out what I need, then it will give me if it is Boyle's law or Charles law. For example now, V1, the first volume that was mentioned, this is what? 100 cm cube, and that's what? 100 cm cube, that's what V1. This is the first volume that was mentioned. Then was compressed at 10 degrees Celsius. You understand? And that's what? T1 equals what? 10 degrees Celsius. Mind you, I said that this one should be converted to what? Kelvin plus 273. So we have 283 K. You understand? So that's that. Then what will be the volume? So V2 equals to what? The unknown. And if the temperature was raised, that's 20 degrees Celsius. So we are going to add 273 to 20 degrees Celsius as well. So if I'm adding these two, so I have what? That's 293. So my temperature here is what? 293 K. We have not even started solving. What we are doing now is writing out our parameters, writing out what we need to solve this question. So I have this, so we have this. Now, let us now go back to the Charles law. No, okay, before the Charles law, look at, in the question I have V1, then we are looking for V2. I have T1, then we are looking for what? Then I have T1, I also have T2 as well. So it means that here we are going to use the what? The Charles law. And what is the Charles law about? V1 over T1 equals to what? V2 over T2. So this is the concluding part of the Charles law. So we have what? We have. So this is complete. So this is the. So we have what? V1 over T1 equals to V2 over T2. Then from the question, we have 100 cm cube over 283 equals to this. And if you look at it, when you cross multiply, we have 100 times 293, then equals to what? 283 V2. That is the cross multiplication. They are elaborating it. So you have V2. You divide both sides by 283, then you have this. So when I decide this number, just to get 283 over 283, just to get my V2, then I have this 100 times 293 over 23. That's 29,300 over 283. And the answer is what? 103.5 in what? In cm cube. So that's just the answer to the question. So no matter how the question is, you just have to follow, get your parameters, write out the variables, and all cannot be given. Anyone that is given, and don't forget that for Charles' law, your temperature should be in Kelvin, so you can be able to convert it from degrees Celsius to Kelvin. And that is that. So we have what? Our final volume of the question is what? 103.5 cm cube. So that is that. So there are other questions. If you check the comment section, I always drop questions there that you can try on your own using this method. So it's not something hard and all that. And I want you to understand that, because I'm going to be dropping some questions in the comment box. So if we have 0.5 dm cube, you should know that 0.5 dm cube is, we are going to be converting this one to what? Cm cube, and that's what, which is equal to 500 cm cube. If you have 1 dm cube, 1 dm cube is going to be what? 1000 cm cube. I think that's the conversion. Then 1 liter as well. 1 liter, because there are some questions that are given to us in liter. That's 1 liter is what? 1000 cm cube, and also 1 dm cube. So if you are studying Charles' law, just take note of these three things for the volume. Then for the temperature, which is always in degrees Celsius to Kelvin, to what? Plus 273. I think that is all about the Charles' law. So you want to look at these other ones now. So I'm going to drop some questions in the comment box. Check it and practice it on your own.